Welcome back to Homework Help with Miss Gore. Today we're going to be talking about our Unit 8, Day 3, Factoring with Different Patterns. So we're going to take a look at question 1 first. In question 1, I'm looking at my two terms here, and I'm going to always ask myself, is there a GCF? So I'm going to think about, all right, well, what happens if I rewrite this with a one-layer box? So in my one-layer box, I'm trying to find, is there a number that goes into both of those pieces? So I'm looking at my 5 and my 10, and I'm noticing that there's a common factor of 5. Now at this point, if you pull out a 5 or a negative 5, either one would be fine. Let's pull out a negative 5. Now they both have an A, they both have a B, they both have a C. Now let's divide that out. I'd be left with C here, and I'd be left with a negative 2 here. So my answer, negative 5 ABC times C minus 2. That is my factored form of my expression. Question 4, x squared minus 12x minus 28. So since this has 3 terms, I'm asking myself first, is there a GCF? Since there is no GCF, I'm going to move to a 2 by 2 box. Now when I do my 2 by 2 box, I make sure that I fill in my x squared in the top left, my negative 28 in my bottom right. And I need to now figure out, well, how am I going to get my middle terms here to add to a negative 12x? So I'm going to think about, how did I get an x squared? Well, that had to be an x times an x. Great. Now I'm thinking about my factors of 28. So my factors of 28, I could have a 1 and a 28. I could have a 2 and a 14. I could have a 4 and a 7. So we need some sort of combination of those numbers. So I'm thinking of the numbers that could add or subtract to get me a negative 12. Well, if I turn this into a negative 14, that would be a negative 14x. Turn this into a 2, and now I have a 2x. I take a look at these terms here. Do they add to negative 12? They absolutely do. So my answer, my factored form, is x minus 14 times x plus 2. And that is my factored form. Let's take a look at number 5. Number 5, again, first question I ask myself, is there a GCF? So I'm looking at the problem and I don't see a common factor in either of these. So I'm going to go to my box method. I've got a 2 by 2 box, and I only have 2 things to fill in. So I'm going to put my 64 here and my negative n squared here. And I'm thinking about, all right, well, what are the only ways that I can get a negative n squared? Well, one of these has to be negative n, the other has to be positive n. The only way that's going to happen. And I'm noticing that I don't have a term in the middle. There's nothing there. So there must be a 0 n in the middle. So that means that the 2 numbers that I fill into my box are going to end up having to cancel each other out. Well, if I think about numbers that are going to multiply to 64, well, what about 8 and 8? Well, that would give me a negative 8n. This would give me a positive 8n. These 2 will be 0. Yay! So factored form, 8 plus n times 8 minus n. Wonderful. Let's move on to number 6. In number 6, again, first question I'm asking myself, is there a GCF? There is no common factor between any of those 4 terms. So I'm going to move to my box. So let's make a 2 by 2 box. And again, I'm filling in my 8r cubed, my first term up here. Now notice that these terms, well, they're different. So let's just fill them in. Doesn't really matter if they go here or here. So I've got my negative 64r squared, my r, and my negative 8 right here. So I've got to think about, okay, is there a GCF now in each one of my rows or columns? So I'm taking a look at my first row right here, and I'm looking at these terms and I'm saying, oh, wow, there's an 8 that they have in common. There's an r squared they have in common. Well, if that's an 8r squared, well, then that had to be an r. And if that's an 8r squared, then this had to be a negative 8. Now I go down here. Well, if that's an r, that had to be a 1. Does this multiply to negative 8? Absolutely. So my factored form is 8r squared plus 1 times r minus 8, and that's my full factored form. Let's try number 7. Okay, let's take a look at number 7. Number 7, okay, again, I'm looking at this and I'm trying to look for my pattern. Is there a GCF? No GCF here. Let's go to a 2 by 2 box. So in my 2 by 2 box, I have a 49, I have a 121p squared. And again, there's no term in the middle, which means there must be a 0p in there. So whatever terms I fill in my box are going to have to cancel. I do notice something pretty good about both of these numbers. They're both perfect squares. So here's a 7 and a 7. That's how I can get a 49. And over here I have an 11p. And, oh, this is a negative. Oops, forgot that. So that's going to have to be a negative 11p. So then I'm going to have a negative 77p here, a 77p here. These two will indeed add to 0. So my answer is 7 minus 11p times 7 plus 11p. That's a horrible 11. Sorry about that one. All right, let's move on to the back. Okay, I want to pick up on question 22. Now, 22 is very, very similar to the others, but there's something a little bit tricky about it. So when I go, I'm going to ask myself if there's a GCF. I notice that there is no GCF between my terms. So I'm going to go to my box method. So I have my 2x squared here and my negative 5 here. And again, I'm not going to fill in my negative 3 yet because I need 2 terms to add to a negative 3. So I'm asking myself, all right, well, how did I get a 2x squared? Well, this had to be a 2x and an x. So I'm thinking about my factors of negative 5. So my factors of negative 5, I might have a negative 1 and a positive 5, or a positive 1 and a negative 5. But remember that whatever gets put into this spot right here is going to get multiplied by 2. So one of my terms is getting doubled and added to the other one. So we can guess and check here, and we could try our numbers, or we can think about which one needs to be doubled. Now I know that I need this to be negative, so let's try doubling the 1. So this would be a 2x. And let's try our negative 5 here. This would then be a negative 5x. These two do indeed add to negative 3. So my factored form is 2x minus 5 times x plus 1. Number 25, I'm going to set this problem up for you, but I need you to solve this one on your own. So Mrs. Golden has 14 coins. Some are quarters, some are nickels. So this doesn't tell us the relationship necessarily, like there's double or triple or 5 more, anything like that. So I'm going to make a little chart. I've got my coin, I've got my number of coins, I've got my value of the coins, and I know that I have my quarters. I know that I've got some nickels. Now, the challenge is, how do I know I'm always going to get 14 coins? So what I'm going to do is I'm going to call one of these terms x, and in order to have them always add up to 14, I'm going to call the other term 14 minus x. Now, these could be switched around. They'll still get the same answer, no problem. When I get to my value column, I'm going to multiply 25 cents times my x. For my nickels, 5 times my quantity. Now I need to take these and I need to add them to 170 cents. So finish that problem on your own, and I will see you